Let me introduce myself. I'm Marius. I'm one of the driving forces behind CocoaPods, a dependency manager for Swift and Objective-C. Among dozens of other contributors, as you can see in the background. Really proud of this community project. Beside that, in my day-to-day job, I work for RAM. RAM is a mobile database, a replacement for SQLite and Core Data. And as you can see on a snippet of our website, we have bindings for Objective-C, Swift, Java, and the latest is React Native, so JavaScript as well. So back to live objects. What is this? Let me answer that by explaining what they are not. They are not immutable or value objects. You might have heard about them. With the rise of FRP, functional reactive programming, these are preached in our communities. And for sure, they are neat. They are simple, and they are automatically thread safe. And depending on your tech stack, you have some more advantages, but in the end, I think they boil down to simplified reasoning, so the first point on the slide. But on the side of the disadvantage, we have that they are expensive, especially with garbage collected language like Java and JavaScript. They have some limitations. Java, for example, doesn't have a concept of built-in immutable collections, so you need to bring your own. Swift structs don't allow cycles. And as a last point, if you have larger object trees, modifications of those can be cumbersome. And on this slide, you see a little asterisk. This is because, yeah, there are concepts like lenses, but those have some overhead. So introducing this overhead to your code base means more effort into understanding what's going on, and might not make it so easy as just value objects alone. So I still see that as a disadvantage. So let's take a look how they look like. So here an example with Swift, we will go through multiple of them, and everybody should see something which is familiar. I just don't have an example in JavaScript. Swift has a baked-in concept of value objects into the language. Those are structs. And even so, these properties here are defined as variables, as you can see from the var identifier in front of them. These structs conform to value semantics because structs, their instances are passed as values and not as references. So even so, you could modify them locally. Those have only local effects and no side effects all over other instances you had. So to qualify this struct here as a value type, the property category would also need to be a struct to be in the same scheme, or also be a value type. And this is a general requirement with value objects. They must be built out of other value objects, and these can be ever undefined value objects, or those brought by the language like string and int here, or further like boolean, float, whatever. So the same in Objective-C. Much more verbose, as we can see. And let me explain especially one detail here. We have different attributes here for our properties, which are really important to define correctly. So we have copy here for strings. Why is that the case? So strings with Objective-C, and a string itself is given as a value object. But and a string has a subclass, and is mutable string, and this is not a value object anymore. So we have to protect our value object here from being able to inject mutable properties. So we use copy here so that we can't set over our constructor a mutable string and initialize our object with that, which would introduce side effects. We don't want to have with value types. So the next one is assign. There we can fall back on the built-in value semantics of atomic types as given in C, we inherit from. And lately we have strong for category, and we can just use strong here because we can rely on category being a value object itself again. So it might not be mutable, and we can fully rely on that. I mean, there could be a subclass theoretically, but if we can't trust ourselves in that, it's not worth the effort, probably. So let me show you some convenience helper method we could define on base of that to make modifications to our value objects or retrieve modified instances. This is possible by defining such methods which return themselves new instances with all other properties being the same beside the one we want to modify. So the same in Java. What comes to attention here is we have a simple class with attributes and a constructor and getters, just getters, no setters here. But in addition to that, we have this little word final in front of the class and in front of our attributes. And this ensures that we ourselves don't define our subclass, which is mutable again. We can enforce that in Java, so let's use it. That makes possible to avoid that we can inject mutable instances via polymorphism. So we could authorize, if category wouldn't be final, inject a mutable category subclass, and it protects our model for example, third-party developers or also new developers to our project, to our code base. Okay, so now we have defined value objects, how to interact with these. I will show that at an example, retrieving an inventory item from inventory schema. Might be an app to manage your inventory, modify its quantity, and persist the change back into the database. And here we see for the Android standard library how we could retrieve via SQLite such an object. We built our query, execute it, and pull out our properties. Might need to do some additional mapping, like mapping the category ID because of the object referential mismatch to a value object again, and finally create our value type we wanted to retrieve. Making modifications to that is possible by creating new instances with modified attributes, and finally persisting the change back into the database will be doing all this process vice versa, mapping our value type to the single attributes and putting them into a dictionary type of collection and executing a query which makes the change on the database. So it boils down to an underlying principle of push to and pull from the database. And as we can see by that, we can limit the state and the side effects in our application, but it's still there, is lurking around. Just because it is hidden, that means it isn't there. So it might be worthwhile to consider alternatives to that. And one alternative is embracing state. And this is possible via the concept of live objects with realm, which is fundamentally different. Live objects always represent the latter state. They are fully navigatable, traversable, but are not necessarily thread safe. For realm, we are working on that. So here, just an example in Swift, in comparison to what we had before, we see that those properties have to be defined as dynamic now. This is we will see that a bit later. I will explain that. And we have a limitation here, also a change from what we had before. Links must be nullable with realm. We can't enforce that there is always a category for our inventory item on base of our schema. So we need to do those validations ourselves. And then we have those steps how to work with these objects, and here everything together on a single slide. So you see already it's a bit simpler to work with these. We retrieve our item and then make a modification to that in a write transaction. So how does that work under the hood? Objects store a reference to the row, and so always carry identity in comparison to the value objects we have seen before, which don't have any identity. And I said I would explain later why this dynamic. Properties are dynamically implemented in runtime, and we hook into the runtime and directly connect the property accessors with your database contents, which is memory mapped. So for that reason, modifications are not arbitrarily allowed, but only within write transactions. And MVCC algorithm makes sure that all necessary versions are around. So you might wonder, MVCC, what is that? That means multi-version concurrency control. And we worked through what that means. So in comparison to MVCC, there is a naive approach of locking. With locking, you would read from your database, read, and then at a certain point you make a write, and everything stops down. No reads, no writes are allowed concurrently to that, just as one write transaction. And finally, when this is committed, then we can allow reads again. So with MVCC, this looks a bit different. So we have our reads again, and then we make a write transaction, and we only need to block writes, overwrites in that case, to ensure that we have one path to our data and no forks in different versions. But at this point, we fork our data and make a new version, while you can still read on the old version. And when the commit is through, you can read again. This a little bit further with a subsequent write transaction now, we can also keep this version around and still read from it while we make a new write. So this is MVCC. And on every commit, all accessors are updated across threads and processes, as long as there's a run loop in place and you don't block it by any other activity. Otherwise, if a thread is blocked, we can't update anything. In addition to that, at the end of each commit, change notifications are sent. And this happens so far per object and also per collection. So if you have some results, you made a query to the database and applied some filters or even sorts. These are also updated and just for the filtered objects. So say for our example of the inventory, I was filtering for all appliance by a category, and I only touched an electrical device which is in another category. I wouldn't get an update for this collection because it doesn't apply to this filter. And in the future, we will also have fine-grained updates, which means I see for a collection what exactly has changed. So was there new data? Was something deleted? So far, you get only this collection has changed as a whole. And finally, as we have seen, the MVCC algorithm disposes all commits which are not necessary anymore. But just if we don't keep track of the accessors and make sure that everything is up to date, which is also, you have to pay attention for that when working with this concept. So you might be a little bit afraid with these different versions. Does this mean the whole data is copied every time? And we use a lot of memory in that process? No, we don't. It's not necessary by using copy on write. But to explain that in more detail, I would need to give you the talk about the birds and the bee trees, because Rome is a giant bee tree in the end. Feel free to get me later and ask me all about it, but not within this talk. That would, explode. So what are my advantages of this concept? And the advantage and differentiation to what we have seen before is you have a single source of truth for your model schema. You define it just in your model in the programming language you use, and not at a different place again in your database, for example. And you don't have any overhead of mapping data around. This is ultimately done by the binding. Or not even done. It's happens via memory mapping, so which is a big differentiation from ORMs, which could make that more convenient, but ROM is not an ORM, it's the binding. You use the database directly in that case, even with those objects which seem so convenient in comparison to what you might know from other objects. And you get change notifications for free, which is cool for binding object properties from your database directly to your UI and work so in a reactive way. You can also automatically update tables and stuff like that. And let's take a further look at that in a little demo. So, can you all read that? Give me a sec. Is that better?
Yes.
Okay. If I go too large, then you might not be able to grasp it so easily, I think. So this is a little reactive example with Realm of a to-do application, so probably the most simple kind of application you can do these days. Most popular as examples. And you see it's basically my travel checklist, what I have all to do. And we see we have here a table of, or a list of all our to-dos, which consists of different cells. And when I click into one of them, I see details about it. I can make modifications to it. I can also do that from the table. And it's all really simple to do. And we will take a look at it. So first, let's check out our model. And as we have seen before in the Swift example for ROM Swift object, we define it in the way it's necessary. All these properties have default values, which makes it easier to work with them, and is required for us to figure out what types those objects have, because the Swift offers limited possibilities to do reflection, so we need instances of the objects, so we need a constructor without any arguments. Just to explain that aspect of it. And then we have our list we control. This is completely based on the standard Xcode example of a master detail project, so I stick with those names. Our master view controller is responsible for showing the list of items. And we see here, which is probably the most interesting part already of our application, the cell UI table view cell implementation. And this binds to a model item, and in the method which is used to attach this item to the cell, we see here how we set up our bindings, our reactive bindings, and this is done via KVO, which you might be familiar with if you have some background with Objective-C and Swift. Ultimately, it is given by Foundation, which is the standard library of Objective-C, and sends notifications when you modify properties. And our database binding for Objective-C and Swift integrate with that and also sends you exactly those notifications so that we can rely here on them. And what we do is we connect the item summary to our text label, the timestamp when we created our item to the detailed text label, and whether the item is completed or not is shown by an accessory, whichever is the check mark or the disclosure indicator to indicate that we can go to the detail screen. And beside that, what we have in our application, which is the really interesting part, is that we set up our collections we work on, which is of type results, as we see here, results of items. And we also observe this notification by adding a notification block. We have to retain this notification token here to keep observing it. And we use the notifications we get to reload our table view. And as we see, so far we sort them only by the created at timestamp. And when we go back to our application, we see that's really the case. When we add a new item, it's added on top of the list. So we could easily modify that if we say, well, I prefer having the latest item on the bottom. Then we can do this as well. And we see it already now that the list is modified here, and it's also working with the auto updation feature. Yeah, and beside that, it's mostly standard code. What we have here is when we insert a new instance, we make a write transaction and directly insert it, as we see, into the database. And beside that, we have to propagate that change to our table view to make the UI update nicely. I mostly worked with storyboards to avoid having all those view setup components here. So you see here's the master table view screen and the detail screen. Yeah, and beside that, taking a look at the detail screen, it's also very straightforward. What we do here is setting up our components with the values given from our item, and then setting up the button action in a reactive way for the cancel and done button. And when done was pressed, then we update the item properties with the fields from the components. And finally navigate back to our list. That's all. And I go back to my slides. And end with asking you about your questions.
Questions time. Hi again, thanks for the talk. I have a question about threat safety, actually. This live object is kind of similar to an S-managed object in core data, as I understand. But in core data we have all these different contexts, and we have to you can't get an object from one context into another. You had to pass IDs or something. So how do you handle it in Realm? It just happens automatically?
How you work between threads?
Yeah, I mean reading-wise, reading objects. So are objects consistent across different threads or not?
So as said, we are not really thread safe in that way that you can pass around your live objects between different threads. When you retrieve an accessor from Realm, it is always bound to the thread where you received it. But it is thread safe in that way that you can safely use them between different threads. And what you could do is using primary keys like IDs. I think you mentioned that, and pass that around between threads and just retrieve your accessors on a different thread again.
Okay, thanks.
Hi, thanks for the talk. I have kind of a similar question, but a bit more general. So, what is the main difference between the live object and NS managed object?
You are asking about the difference between live objects and NS managed objects, or
Yeah, because NS managed objects have the ID under the hood and they are binded to the data source where they came from.
So with NS managed objects, it's basically an ORM on base of SQLite, and you retrieve the data at the moment when you retrieve an NS managed object from your database, and then work with the data you received at that moment, and you can make modifications to that and propagate it back to the database. While with those live objects, you directly work on the memory mapped data. So there's no additional copying of attributes involved. So with the memory mapping, we take what is written on your file on disk exactly like it is into the memory, and your accessors make sure we are knowing the offset in their tables that you write and read from that part of the memory which is relevant. Does that answer your question?
Yes. But when we work with NS managed objects, there is this concept of scratchpad. Like we can modify data and we will write it down only if we decided to. So in case of leaf object, we have to rewrite them to the initial state and save it.
Yes, you could open up. It really depends on your use case. So your question was about being able to make draft modifications to your objects, I guess, which you are able to undo if you decide at a certain point that you want to keep them around. So what you could do to achieve that, but it really depends on your use case, is opening up a write transaction, which has the implication that it blocks all over write transaction, which will happen. So that's the thing you have to take care with, and make your modifications to the object. And when you finally decide that you don't want to keep them, instead of committing the write transaction, you could discard it instead, and everything would be lost. Or you commit it to the database and then go back and revert it, but you don't keep the reference necessary around. You would need to do that perhaps then by retaining the old version and making sure that this is not updated, but this has also other implications, like using much more memory than you would need. So in that case, it might be more helpful to rely on a similar concept like value objects for that specific use case, and get a copy of your data and work on base of that and copy it back to your live objects.
Hi, thank you for your speech. And my question is there any tools to access data live object outside of application, like command line tools or GUI or so?
Sorry, I didn't get the question. So,
is there any tools to access data outside of programming way, but like SQLite 3, select and so?
Also, so your question was about being able to outside of the app, for example,
yes.
using the database you have. So we have a browser which allows to interactively explore your data, UI solution to do that. But What we don't have in comparison to SQL or SQLite is SQL as a query language. We integrate instead with the host language, like for example with Objective-C, we integrate with NS predicate, and you are able to use those and a DSL, which allows a type-safe usage of your data.
Okay, thank you.
I just wanted to answer your question. They also offer an app, I mean Mac app, where you can just open your Realm database and view all the grid and all the rows, and you can modify and everything you have.
Yeah, thanks for that. Very welcome. That's the Realm browser, the UI solution I mentioned.
Yeah, thank you for your speech. And my question is, maybe depends to the previous one, is about the Realm browser. In your presentation, you told that a live object can be synced across the threads and across the processes. So, I mean, if you modify the object in one thread, it's updated in another one. So, can I edit data outside the app, and then this data updated inside the app? For example, if you run app in the simulator and open Realm browser simultaneously, and then change data in one and see changes in another one.
So the question was about whether I can access data from simultaneously from the browser and, for example, an iOS application, and modify it at one place, and whether the updates to the database will propagate to the other place. And yes, that's the case. So if you modify the data from the browser, your iOS application will represent your modifications you made there.
Yeah, thank you.
Thank you for the speech. My question is, if we modify data in one thread and not commit these changes and read this data in another thread, so we will get the changed version or previous one that was before changes in another thread.
So you can only make modifications to your data when you are within a write transaction. So your question was about when you start a write transaction, make modifications to it, but don't commit the write transaction, but pass around the accessor to another thread? Did I got
yes,
that right?
if we changed some properties on some object and didn't write it to the database, so it only exists in memory and not on the disk yet. But in another thread, we are trying to access some property of this object, and what we'll get.
You will get the old version. As long as the write transaction is not committed yet, you will still get the old version. That's the atomic principle of databases, that transactions, while you're within a write transaction, those changes don't propagate yet to the database first when it is committed.
Okay, thank you. So. And as well, we can only change the properties on these objects just inside write section, right?
Yeah.
Okay, thank you.